product rule of differentiation? If we have two functions, then what was the product rule for the derivative?
First function derivative of second plus second function derivative of first.
Right?
Yes.
Now, if we take integral of this whole equation, integral of this part, integral of the right hand side, or you can write it as integral f of x g dash of x dx plus integral g of x f dash of x dx. But on the left, you see this is the derivative, and on the derivative you are applying the integral. So these two guys cancel out with each other. So this dx is removed. So on the left we are left with f of x g of x, right?
Yes.
Because this is a whole derivative of everything written here. If you have a whole derivative of everything and you apply the integral on it, then integral cancels the derivative and you get the within the material. But here it is not cancelled because these guys are not the whole derivative. One is derivative but the other guy is some function. Now if I write this equation like f of x g dash of x dx on one side, this guy on one side, and put this guy here, it becomes f of x g of x minus integral g of x f dash of x. Is it okay? I just took this here. So this is minus this, and this guy is on the one side. Now, suppose this is equation 1. And in this whole equation, we have two things. One is f of x and one is g of x, and everything is working on them. So if I assume that my u is equal to f of x and v is equal to g of x, then the derivative of u means du, it is f dash of x and a dx. Similarly, the derivative of v will be dv g dash of x and a dx. If I substitute all these things here in the equation 1, then equation 1 will look like f of x is u, g dash of x dx, g dash of x dx is equal to dv. So it is u dv equals to f of x is u into g of x is v minus integral g of x is v, f dash of x dx is equal to f dash of x dx is equal to du. And if I say this is equation 2, then both of these equations are representing the formula of integration by part. So if you have two functions multiplied together, then you can assume, because you have to figure out this side for any integral. To figure out this whole side, It means if you have two functions multiplied together, then you can assume one of them as f of x and the other guy as g dash of x, not g of x. And obviously g dash of x has dx. We will do an example and you will see this. So you are going to make two parts of the whole statement written inside, which is the integrand. So you are making two parts of the integrand, and when you make the parts, then you will apply this formula and it will give you the answer of the whole integral. So whatever formula is easy to remember, you can memorize it, whether this one or this one. In case if sometime you forget this formula, no need to worry, just go back to the derivative formula, which is very simple, and put the integral on it and you will get the integration by parts formula. So this is equivalent to the product rule of the derivatives. So the integration by parts is just like the product rule in the case of derivatives. Let's have an example. Suppose we have integral x sine x dx, and we will try to apply both of them, like we will try to use both of them to see will it work or not. So if I am simply considering f of x or g of x, now when you are making the parts of the integrand, it will be your choice to make the parts, but you have to keep in mind that if you are making this guy as the second part in the formula, like if you are making it as g dash of x dx, it means you have to apply integral on it to get the original function g of x. And if you are making this guy as f of x, it means you are going to apply the derivative on it to make it f dash of x. Because look here, if I assume f of x is equal to x, and you have to make the assumptions according to the right hand side of this formula. I have assumed x as f of x. It means now the rest of everything is equal to g dash of x dx. Sine x, right? So if you are assuming this guy as the second part, then it means you have to apply integral on it to get the g of x. And if you are making this guy as f of x, it means you have to apply the derivative on it to get the f dash of x, because you need four things in the formula. You need f of x, you need f dash of x. You need g of x, you need g dash of x. Now from this information, you have, according to the formula, you have assumed two parts. One part as f of x and the other part as g dash of x dx. Now what is remaining? I need f dash of x dx and I need a g of x. If I have all these four informations, then I can simply put them into this formula and I will get the answer. Now to get f dash of x dx means simply differentiate this equation. So it is 1, right? And this is g dash x dx. And to get g of x, it means you have to integrate this equation. You have to apply an integral on this equation. So when you apply integral on it, it means you are applying integral on sine x dx, and you know how to solve this integral. The integral of sine is minus cos x. Now, and this thing, you know that this is the total derivative of something, and total derivative of something together with integral cancels each other, so this becomes g of x. Because this whole thing is total derivative of g of x. So this is similar to, like, this is just like d by dx of g of x. So if you have a total derivative of something and you are applying integral on it, these two guys cancel with each other, so this becomes g of x. So now you have all the information. You have g of x, you have f dash x dx, you have f of x, you have g dash x dx, and all these things are complete here to complete this formula. So I can say that integral f of x g dash of x dx. What is f of x? F of x is equal to x. G dash of x dx is the second remaining guy. It is sine x dx. So it means this is exactly equal to the question statement. And this is equal to what? The right hand side of the formula. F of x means x. G of x means minus cos x. Minus from the formula. Integral g of x means minus cos x. F dash of x dx means this guy.
1.
So it is simply 1 dx. And this becomes minus x cos x. This minus into this minus plus integral cos x dx. And now you know that integral of cos x dx is, what is the integral of this? What is the integral of cos?
Sine.
Sine. So it is sine x plus the constant of integration. So this is the answer of this question according to the formula. Or if you assume u is equal to x, and so in the formula you see you have two things. If you are assuming one thing as u, then you have to assume all the remaining thing as dv. So I have assumed x as u, it means whatever is remaining I will assume it as dv, and the dv will be sine x dx. One thing you should keep in mind, that this is not the substitution. In the case of substitution rule, we were actually changing the variable. when we were applying something, we were saying, let's suppose u is equal to x square plus 1. Then what we were doing? We were converting the x into u and we were solving the integral. That thing you should not confuse yourself here. Here we are not changing the variable. We are just assuming these two things just for our convenience to write into this formula. But actually into the formula we are keeping the same variable. This assumption is just for the clarification that okay, which part is first one and which part is second one, just to make it clarify. This is not the substitution. No. Understand? Don't confuse yourself with the substitution. Now I have u. In the formula I need du. So from here I can get du, which is 1. Similarly, it is dv. If I apply the integral on it, it will become v, because this is the derivative of v and integral will do this thing. And on the right, it will be minus cos x. Everything is same, just the names in the two cases are different. Here, the names of these things were f of x, g of x, and so on. Here, the names were u, dv, du, v. So, only difference in both of these formulas is the names. Here, you don't have any x expression. Actually, u means u of x. But just for simplification, to keep it very short, we don't write it as u of x. We just write it as u. So both the formulas same. Both will work in the similar fashion. The only difference is the names of the functions. Another example, solve the integral ln x dx. Now look, in this integral, you have only one function, ln of x. But we have already studied that 1 is also a function. F of x is equal to 1 or g of x, whatever you name it. This is also a function, and this function is called a constant function. So the guy ln of x is multiplied with a constant function. And in that case, you can assume u as ln of x. And why you are assuming u as ln of x? Because the derivative of ln of x is very easy to calculate. And you can assume g dash of x dx as 1 dot dx, the remaining part 1 dot dx. And why we are assuming this? Because when we will integrate, we know that integral of 1 is x. So from here, du will be 1 by x. From here, g of x will be x. And if you want to put c here, no problem. If you don't want to put c here, you can put it in the final expression. C you can always give in the final expression. So now you have all the information, and just put them back into this formula, and yeah, the answer will be integral ln of x dx is equal to uv x ln of x minus integral g of x is x, f dash of x is this guy 1 by x, again dx. So these two x will cancel, will be x ln of x minus these two cancelled, and this dx with the integral will give you an x plus the constant of integration. Now let's have a little bit difficult than this. Integral t square e raised to the power t dt. So the integral is in terms of t, not in terms of x. Do not, you know that you can always write any variable of your choice. Now you tell me which one should be the first function and which one should be the, in case of, for example, we are adopting the uv formula, then which one should be the u and which one should be the dv.
Can't you take anyone like you or David?
You can take anyone and you can try to solve, but if you take dv as t square, when you will take the integral of dv, it will become t cubed by 3. It means the function is not simplifying, it is going forward. But if you take t square as u, then of course if you are taking it as u, then you will take the derivative of t square, and when you take the derivative it will become 2t. But you can, it's not that the other way it will be wrong, no. The only thing is the other way it will be complicated, complex, more work have to be done. In both cases you will get the same answer, and sometimes you will not get the answer because you have chosen a function which is never solved by the integral. So it will keep going, keep going, keep going. So in that case you will not get the answer. So you can always have a choice to choose any one and try to solve. If you fail, then go back and choose the other, switch them. So you can always do that, but sometimes if you choose wrong one, you will stuck somewhere. But in simple functions, both ways work. So if you take t square as the u and dv as et dt, then du will be 2t and v will be et, because derivative of exponential function is always the same, integration of the exponential function is always the same, so that's the same, and here it becomes 2t dt. Now if we put these things into the formula, I will be,
Okay, integration on both sides and dv. Integral on both sides.
yeah, of
Yes.
course, when you will put integral, you will put it on both sides. On the left side, this d cancels this integral,
Yes.
so it becomes v. On the right side, you solve it by your knowledge and it becomes et. Now this I, which is integral t square et dt, this is equal to the right hand side of the formula, uv. U is t square, v is e raised to the power t, minus from the formula integral v is this guy and du is this guy, 2t dt. This is equal to t square et, take the 2 outside, it becomes 2 integral et t dt. Now look, still you see this integral, in the previous example this became simple and we solved it by our knowledge, but here it is again in the form of integral f of x into g of x, two functions multiplying together. So you have to use again integration by parts. So you will write it as t square et minus 2, let me say this is I1, this guy, and this is equation 1. Now first I have to solve this I1 again following the same method, and we will put that answer here, that will be the total answer. So my job is now first to solve I1. I1 is equal to integral et into t dt. Now, since we have assumed u as t square, so it is better to adopt the same way. Again, assume u as the polynomial, this polynomial. Now, the power is 1. U is equal to t, and if this is taken, then the rest of the material is dv. This is et dt. So, du will be dt, and integral on both sides will give you v equals to et. Now put this information into this formula again for this I1. Now we forget about that. We are only dealing with this I1, which is the mini integral of the same type. So put this information into this formula. So your I1 will be, that is integral of et t dt. It will be uv t et minus integral v is et, du is dt. And you know that integral of et dt is what? Tet minus et plus, let's say this is c1, a constant of integration coming from this integral. Now, in this case, it was not simple. It was a composition of two functions. So we have to apply again the integration by parts. But when we done it again, in this part, now it is simple function, exponential and the integral of exponential. So whole thing is solved. No integral is involved. So suppose this is equation 2. Now I can use this 2, and this 2 is equal to I1. I can put this 2 here instead of I1. So my bigger I will be t square et minus 2 into the value of I1 which I have solved here, t et minus et plus c1. You multiply them together, it is t square et minus 2t et plus 2 et minus 2c1, and let me write it as c, and I can say that c is equal to minus 2c1, because when you multiply minus 2 with a constant, again you will get a constant, and I name it as capital C. This is the answer of the bigger integral. But the only difference here was what? On the first part, we applied the integration by parts, and instead of getting the answer, we got some answer, but some part is again an integral in the form of composition of two functions, the product of two functions. So we have to apply the same product rule, the integration by parts, on the mini integral separately. Solve the mini integral, but the same procedure, but solve it separately. Whatever the answer you will get, put it back into there, and that's your final answer. Is it okay?
Yes.
Now, suppose we have integral e raised to the power x sine of x dx, and we are assuming u is equal to e raised to the power x. If it is u, then the rest is dv. So dv will be sine x dx. In this case, both the functions are almost very common and familiar to you, so you can pick up any two. in any question you can pick up any two. But if you will, if you do some 1 minute work on analyzing the things, then you will not have the chance of stucking somewhere. If you just randomly pick up, then if you have chosen the wrong thing, you will stuck somewhere or you will do more work. The answer will always be same. So in this case you can pick up anyone, but we will see what will happen next. Now this is u, then the du will be again ex, and here integrated it will be v, and the integral of sine x is minus cos x. So we have all the information, we put them into the formula. So my I will be integral ex sine x dx will be uv e power x minus cos x. So I am taking minus here, it becomes e power x cos x minus from the formula integral, and v, which is minus cos x, so let us take the minus outside, it becomes plus cos x, and du, this guy, e power x dx. Again the same problem. So we have solved this thing, and if I say this is the integral I, okay, let us write similar way. Now again we have an integral in the form of composition of two functions. So we have to apply the integral again. But if you will apply the integral again, you will see, you will get again this function in the form of two composites. Now this was e power x sine x, here it is e power x cos x. If we will adopt the same procedure, in the next integral, you will again get e power x sine x. You will again get e power x cos x if you keep repeating this. So let's see what happens. So I'm saying this guy is I1. Let us solve it here directly. So this becomes minus e power x cos x, and now let us apply the formula of the integration by parts, and we are assuming that u is equal to e power x and dv is equal to cos x dx. So du will be e power x and v will be sin x. So I'm going to apply the integration by parts inside the bracket. For this, integration by parts will be the same formula, uv e power x into v sin x minus from this formula, and v will be integral, inside the integral v is sin x and du is e power x with the dx. And this expression we have got by applying the integration by parts formula on this integral. And this integral, similar to this, gave me this thing inside the bracket. Now you see, again we have got one integral which is in the form of composition of two functions, one here, one here. But let's see, can we simplify it? It becomes minus e power x cos x plus e power x sin x minus integral e power x sin x dx, and this whole thing is coming with the left hand side, this guy. So this guy is on the left hand side, this is e power x sin x dx. So you see, this and this are same. So I am allowed to move this guy on the left hand side and add them together. If I add them together, it becomes one is this and one is this. So 1 plus 1, 2 integral of e power x sin x dx, right? Is it right or not? If you are confusing, tell me.
More complete.
And on the right side, only this expression is left. So we have this with the 2. You can move this 2 downstairs there. So it becomes this guy divided by 2, this guy divided by 2, plus a constant of integration. And this is what? This is the question. So it means we have got answer, and there is the only thing when we are doing integration, that your answer must not have an integral and any term. You should eliminate all the integrals. So you can see this is the question, and the answer for this question has no integral. So that's it. So this is your answer. So in this case, in such cases, when you will do 2 times integration, you will switch back to the original question as a sub-integral. So you can always move them on the left side and add them together. Similar will happen if you have integral e power x cos x dx. Similar thing will happen. You will do 2 time integration and you will get a same expression. You can move it on the left and add them together. That's it. Okay?
Yes.
Integral 0 to 1 tan inverse of x dx. What to do? We can try assuming these two guys. We can assume u is equal to tan inverse of x and dv is equal to 1 dot dx. The derivative of du will be this. These derivatives are given in the table for the derivative section. The inverse function of tan, the derivative of inverse function of tan is 1 plus 1 over 1 plus x square. Yeah, with the dx. These things are already we have done in the differentiation. The derivative of tan inverse is 1 over 1 plus x square. Similarly, the integral of dv will be v and integral of dx will be x. So you can put them into the formula, and the formula will be the integral from 0 to 1 tan inverse dx is equal to u into v, that is x tan inverse x, minus from the formula integral v is x, du is 1 over 1 plus x square dx. Now this is okay, x tan inverse of x, no integral, minus, you see this is equal to x dx over 1 plus x square. And if I write it like this, you should have no problem with me. I multiply and divide with 2. Now look, the expression downstairs, the derivative of this expression is 2x dx. The down expression is 1 plus x square. And if you take the derivative will be 2x dx. This derivative is present on the upper portion. So yesterday we were talking about it, that when you talk about the derivative of ln of x, you say the answer is 1 over x. In the case of integral, if some function downstairs has the derivative on the upper portion, then you can simply write it as ln of the function which is written downstairs. So it means we can write it as x tan inverse of x minus 1 by 2, since the lower function has the derivative on the upper portion, so the whole integral can be replaced with the ln, and inside the mod you can write 1 plus x square. And one thing important, because this integral was in between the limits, so you will put the limits here, limit from 0 to 1 on the first expression, and this integral again from 0 to 1. Similarly, limits from 0 to 1, minus 1 by 2, integral 0 to 1, and this will be limits from 0 to 1, minus 1 by 2, ln of 1 plus x square, limits from 0 to 1. And you can put the limits and simplify it. Right? Can you put the limits? If you put the limit here, it will become, the first limit is 1, so it will be 1 dot tan inverse of 1. The second limit is 0, minus 0 dot tan inverse of 0. This is first part, minus 1 by 2 ln of upper limit is 1, so 1 plus 1 square, ln of 2, minus lower limit is 0, 1 plus 0, ln of 1. Simplify them and you will get the answer. Okay or not?
Can you repeat this question?
From where?
Start. From start. Very difficult.
This is the question statement. So first function, we know that we can easily find the derivative of tan inverse, because this derivative is given in the table in the when we were solving the derivatives. So we have made a list of the derivatives of simple trigonometric functions and inverse trigonometric function. So the derivative of this guy is easy to calculate, so I can assume it as the first function, and they are easy to calculate the integral, so I can assume them as second function. So u is tan inverse of x, and I know that the derivative of u is du, and the derivative of tan inverse of x is 1 over 1 plus the variable square. X is here, so it is 1 over 1 plus x square dx, and the integral of this guy is v, integral of this guy is x. So we have all the data which we need to put into the formula. So it means this integral from 0 to 1 tan inverse of x dx is equal to what? This is equal to uv. U is tan inverse and v is x, so I am writing it as x tan inverse of x, but in this case the integral is having limits, so whatever expression you will simplify, you will plug in the limits on it. Whichever expression is simplified, you have to plug in the limits on it, because the whole integral is under the limits. So this expression is under the limits, minus we have another integral, but the limits will be the same. Limits is again 0 to 1, and this integral is from this formula. So v du, v is x and du is 1 over 1 plus x square dx. Now suppose this is I.
I will put integral on first part.
Here?
Yes, this is not in formula, right?
No. Look, this thing this thing is coming from this part.
Yes.
But this whole thing is coming from this integral on the left. So whatever the limits are on this integral, you will have to apply them on everything on the right side. This thing already simplified, no integral. So you know that when you solve an integral, for example, x dx from 0 to 1, when you solve it, it becomes x square by 2 under the limit 0 to 1. So the
So you're not taking integral, just you putting the limits.
Because this is a simple expression, it already do not have any integral. Look.
Yes, that's
so we just putting, but you have to put the limits. I will tell you, so we can rewrite the formula for the definite integrals also. Okay, let me write the formula for you first. This same formula, if this is the formula for the indefinite integral. So if we have integral under some limits u dv, this will be equal to uv under the limits a to b minus again integral from a to b v du. So if you have definite integral, the formula is same, but you have to apply the limits on every part of the whole sides.
Yes.
Left and side. So here, this is under the limits, okay? So this guy, you have to write like this. It will become 0 to 1 and this whole thing. Now, when you put the limits into this guy, the first limit is 1. So 1 tan inverse of 1 and tan inverse of 1 is pi by 4. So it will become pi by 4 minus the second limit, that is 0 into something, it becomes 0. So this whole has this answer. Minus, let me say this is I1 and this is my equation 1. Now I1 is, so I am going to solve this I1 separately to not confuse, and we solve it separately and then put it back here, the answer. So I1 is the integral from 0 to 1 x divided by 1 plus x square.
But it's not the product, right?
Yeah, it's you already know how to solve it. So we don't need to apply the product rule here. You can try applying the product rule, but it will fail because this is something in the form of quotient. And we already know how to, and this is simpler than the product rule. That is why we already know how to solve it, and maybe you have solved one example exactly this. In this case, one thing is you can assume this guy as a new function t or a new function u, and you can solve this thing. Should I assume new or I should go directly here?
Assume new.
Okay. So let us assume, since we have already assumed u here, and in the substitution rule, we usually assume u. So here we already have u. So let us assume it as something like t. So we are going to make a substitution t, and I told you that when you are making the substitution, took the complicated guy as the new substitution. So in both these guys, the lower one is the complicated, so I am assuming t equals to 1 plus x square, and the derivative dt will be 2x dx.
Yes.
Now I am going to change the whole integral, the variable of the whole integral in terms of t from x to t. In that case, we know that when we are making the substitution, then we also have to apply the substitution on the limits. In this case, we were not doing the substitution, I explained already. We were not changing the variable inside the integral, so no need of changing the limits. But here, we are going to change this whole expression in terms of t, the new variable. So we have to convert the limits also in terms of t. Now, how to convert the limits? You see, when x is equal to 0, it means t is equal to 1 plus 0 square. T is equal to 1. And when x is equal to upper limit 1, it means t is equal to 1 plus 1 square. that is 2. So the new limits are from 1 to 2 for t. The limits are 0 to 1 for x, the first variable. Now the change of variable will be this. So my integral I1 will be under the limits 1 to 2 in the form of new variable. Now look, to x dx is present here, so you can put this 2 below dt. So now I need this information to replace with this one. So integral will be x dx means dt by 2 and whole divided by 1 plus x square mean t. So this is equal to 1 by 2, this 2 I am taking outside, integral 1 to 2 dt by t. And you know that if something is written downstairs and the derivative is upstairs, it is a natural log of that thing. So this becomes 1 by 2, the ln of what? Ln of t. Under the limits 1 to 2. These two limits. So when you simplify it, put the limits into it, plus, no, there is no need of c, so it will become, I1 will be 1 by 2 ln of 2 minus 1 by 2 ln of 1, and ln of 1 is always 0. So this is equal to 1 by 2 ln of 2. See, this is the answer of the mini integral I1, which is here. So I can put this answer here. So my final answer will be, the final answer of this expression, integral 0 to 1 tan inverse x dx is equal to pi by 4 minus I1, and I1 is 1 by 2 ln of 2. Okay. So definite and indefinite integral, we don't care about the limits, so this way.
Yes.
Definite integral, you have to take limits with every expression.
Right.
We have a formula which is called reduction formula. We already have now simple way to solve the integral. Then we have solved the integral using the substitution rule, and now we already know solve the integral by using the product rule. And in the product rule, we know that how to solve indefinite integral and how to solve the definite integral. Now we have one formula which is called reduction formula, and this formula is integral sine raised to the power nx dx is equal to minus 1 over n cos x sine n minus 1x plus n minus 1 divided by n integral sine n minus 2 x dx, subject to that n is greater than or equal to 2. So in this formula you can only apply if the value of n is greater than or equal to 2, and this is the formula which we use to calculate, for example, sine 60x. So if somebody asks you to find the answer of this integral, then you can simply take n is equal to 60, put this n is equal to 60 in all the places where n is involved, and simplify the integral. That is your answer. So integral sine raised to the power 60x dx is solved by using this formula, and this is called the reduction formula. So let us see how this formula is coming. This formula is a consequence of the product rule. So we actually have to prove that this left hand side is equal to this right hand side. So let us take the left hand side and try to reach the right hand side. Now in this left hand side I want to make something like the product of two functions. So I can split these two functions like this. If I write it as like sine raised to the power n minus 1x, now I have taken one sine x from the total n sine x. These were total n factors of sine. I have taken out 1. So the leftover are n minus 1. So the one which I have taken out, I am going to write it here, sine x dx. Do you allow me to do this?
Okay.
Is it okay? I have your permission. Now I have something to make u dv. So if I assume that u is equal to sine, this and this are same, I simply wrote them in two parts. This is just like you are taking one thing. If you have total n, you are taking one thing out of it and writing them as n minus 1 plus 1. So you have taken one guy out of the total n. So the leftover is n minus 1 and the one guy is ahead of it. So both are actually equal to n. This is also n, this is also n. So the same is here. I just separated it to make uv. Now if I assume u is equal to the first person sine n minus 1x and the rest of the thing is dv sine x dx, then the derivative of this will be du, and according to the power rule it will be n minus 1. This guy will come here and this function will have 1 less than this power. So the sign will have n minus 1 minus 1. This was the actual power and this minus 1 from the power rule of the derivative. So this will become n minus 2. Again the derivative of the simple sign according to the derivative rule. So the derivative of simple sign will be cos x dx. And on the other side, this guy will, when we take the integration, we will become minus cos x. Now we have all the information to put into this formula. So my integral, this thing which is actually equal to this thing, so instead of writing this, I can simply write this. They both are same. I made this splitting to make these factors. So it is my choice to here I write this one or this one, both are same. So I'm writing this because we need this on the left hand side. So both are same. So on the left we have sine raised to the power nx dx is equal to, now we are going to make the right hand side. So the right hand side is this formula. uv means sine raised to the power n minus 1x, this is u, into v is minus cos x. So minus I'm writing here and this is cos x, minus from the formula and the bigger integral, and we have v which is minus cos x, so it will become plus cos x, and du, this guy. So this guy is multiplied n minus 1 sine raised to the power n minus 2 and another cos of x and a dx. Now we have two cos x in the multiplication, so we can multiply them together. It becomes minus cos x sine raised to the power n minus 1x, I just rearranged it, and plus n minus 1 is a constant, so I can take it out of the integral, and inside cos into cos becomes cos square x, and sine raised to the power n minus 2x and dx. Any problem?
No.
Now, I know that sine square x plus cos square x is equal to 1 according to the Pythagoras theorem. This means cos square x is equal to 1 minus sine square x. So I can replace this cos square with 1 minus sine square x. So it becomes minus cos x sine n minus 1x plus n minus 1 integral 1 minus, instead of this I am writing this 1 minus sine square x into this sine whose power is n minus 2 into a dx. Now again simplify them here. This becomes minus cos x sine raised to the power n minus 1x plus n minus 1. Let us write them separately. This whole thing will multiply with 1 and this number 1 integral. This whole thing will multiply with minus sine square and this number another integral. So the first integral will be n minus 1 integral 1 multiplied by this number. So it is sine raised to the power n minus 2x dx plus again this number, because this number is multiplying with all the expressions, again n minus 1 and the integral. Now the first and this whole thing is gone, simply multiplying them together. Now the second thing, minus sine square into sine raised to the power n minus 2. When you multiply sine square with sine raised to the power n minus 2, it means you are going to add the powers. So it will become sine 2 plus n minus 2. So it will become sine raised to the power nx. So this into this will make a sign but a negative sign. So this will be negative and the multiplication will make sine raised to the power n of x dx. And now I can take this whole thing on the left hand side, which is this, because I can see something common in between them. So if I take them on the left, maybe we can cancel out something. So I'm going to take this expression on the left side, which is this guy, right? So my left side is this, which is integral sine raised to the power nx dx plus this expression I'm taking on the left, so negative will become positive. It is n minus 1 integral sine nx dx. This whole thing finished. On the right, now the leftover. The leftover is minus cos x sine raised to the power n minus 1x plus n minus 1 integral sine n minus 2 x dx. All finished. So now we can also split these. One time it will be this will be multiplied with n, another time this will be multiplied with minus 1. So it will become integral sine nx dx plus n into this whole integral. So it will be n integral sine nx dx, then minus 1 into this whole integral. So it will be minus 1 integral sine nx dx. On the right we have minus cos x sine n minus 1x plus n minus 1 integral sine n minus 2x dx. These two cancelled, so it becomes n into this on the left and this guy on the right. So I can take this n, divide both sides with n, So this will be removed from here and it will go downstairs here. So it becomes integral sine nx, which is exactly the left hand side of the reduction formula, and on the right you can split the n with two terms, so it becomes 1 over minus 1 over n cos x sine raised to the power n minus 1x d no dx plus n minus 1 divided by this n integral sine n minus 2 x dx, which is the reduction formula for sine theta. Now we have the same reduction formula for cos theta, and you guys have to help me to do it in the similar way. Let me write the formula for you and you are supposed to prove it. Right?
Yeah.
Okay, 6. And the formula for cos will be a little different, only some minus plus and some terms in terms of cos. It is cos raised to the power nx dx. It equals to 1 by n cos of n minus 1 x sine of x plus n minus 1 divided by n integral cos of n minus 2 x dx. So you see, wherever there was cos, it is replaced with sine, and the sine is replaced with cos, and some here it was minus in the case of sine, now it is a plus, because when you will solve the integral for sine, and when you will solve the integral for cos, it will give you a plus sign, and in that case we were solving an integral for the sine, it gave us a minus cos. Oh, that minus appeared here. The things are same. So what you have to do,
I didn't understand.
okay, what you have to do, simply take this left hand side and write it as like cos raised to the power n minus 1x and a simple cos x and a dx. These x are actually this x. These x are not simple x, okay? Don't confuse yourself to multiply with x. No, these x represent the angle. They are not the simple x. Now you have two factors. Assume u is equal to cos raised to the power n minus 1x and dv is equal to cos x dx. I'm going to share the picture of the sine version so that you can check it and do the same. You have to do the same, only the calculations will be different. Is it okay?
It's same as the other one.
Totally same, only
Okay.
the calculations will be different. Same
Right.
pattern, just keep going, and when you have one time, when you will have somewhere you will have sine square x, you can replace it with 1 minus cos square x from the same formula. In the case of sine, we replaced cos square x with 1 minus sine square x. So
Okay.
this formula is same. Sine square is always equal to 1 minus cos square, and cos square is equal to 1 minus sine square, because both of them are coming from the circle formula. Sine square plus cos square is equal to 1.